Good afternoon. Next topic is slip power recovery scheme. So what do you mean by slip power? What is slip? It is nothing but the difference between the synchronous speed and actual speed of the motor. Okay, so we can write the slip as ns minus n by ns, where ns is the synchronous speed and n is the actual speed, which is expressed as percentage of synchronous speed. Here we are considering a three-phase, a slip ring induction motor. So what is a induction motor? The rotor receives electrical power by induction principle. That's why it is called induction motor. We have two types of induction motor. One is squirrel cage induction motor and the other is slip ring induction motor. So in squirrel cage induction motor, the rotor bars will be short circuited with the help of end rings, whereas in slip ring or wound rotor induction motor mainly used for speed control application, that is variable application. Most of the variable speed application we are preferring slip ring or wound rotor. Here we are having three-phase supply lines. So these three-phase supply lines are connected with the slip ring induction motor and it is connected with one rectifier. So what is a rectifier? Which converts AC input into DC output. So it rectifies the AC input into DC output. Here we are using three-phase rectifier and here we are using diodes as the switching elements and we are having smoothing inductor. So the supply lines are connected with the slip ring induction motor. So slip ring induction motor are provided with that is variable resistances so that you can have speed control, and it is connected with the bridge rectifier. So bridge rectifier, what it will do means it converts AC input into DC and the DC output which we are getting will be having ripples, that is unwanted signals, harmonics. So that can be smoothened with the help of this smoothing inductor and then again it is converted into AC with the help of inverter. Okay, so here we are having a three-phase transformer circuit that will step up the voltage and again it will be fed back. So instead of wasting slip power in the rotor circuit, we are pumping back again to the supply lines. That is the main aim of this topic, that is slip power recovery. What do you mean by recovery? Instead of wasting slip power in the rotor circuit itself, what we are doing, again we are pumping back the power to the supply lines with the help of this three-phase transformer. That's why it is called slip power recovery scheme. So in slip power recovery scheme, we are having a slip ring induction motor. So slip ring induction motor is nothing but it is an induction motor with varying resistance, so that the resistance can be varied at the time of starting. So speed control is possible. And here we are having three-phase supply lines which is connected with the slip ring induction motor. So that slip ring induction motor is connected with the bridge rectifier. What do you mean by bridge rectifier? It looks like a bridge. Here it is a three-phase bridge rectifier. How can we say that it is a three-phase bridge rectifier? Means here we are having 6 diodes. So the diodes are used as switching elements. Diode is an uncontrolled element. It is not a controlled element, so that the output is not in a controlled manner. That's why it is called uncontrolled rectifier. So why we are calling it as rectifier? It converts AC input into DC output. That's why it is called rectifier. Why we are calling it as a bridge rectifier? Means it looks like a bridge like structure with the 6 switching elements, nothing but diodes we are using. And then here we are having a smoothing inductor. So what is the main function of smoothing inductor? Means here we are getting DC output. That output is having ripples. That ripples can all eliminated with the help of smoothing inductor and then it is given to the inverter. So inverter, what it will do? It is nothing but DC to AC converter. So rectifier means it is AC to DC converter, and in inverter it is nothing but DC to AC converter. So that AC output will be again stepped to the, that is pumped back to the supply lines with the help of transformer. What is a transformer? It transfers electrical power from one circuit to other without change in frequency. So here we are using three-phase transformer. So the AC power is again pumped to the supply lines with the help of this three-phase transformer. So the main idea behind this slip power recovery scheme is, instead of wasting slip power in the rotor circuit, it can be pumped back to the supply lines. That's why it is called slip power recovery. So we are not at all wasting the slip power. You know what is slip? It is nothing but the difference between synchronous speed and actual speed of the motor expressed as percentage of slip. So that power, instead of wasting in the rotor circuit itself, we are using in a useful way. That is, we are again pumping back to the supply lines. For that we are having two main elements. One is rectifier and the other is converter. So here the induction motor is supplied from three-phase supply lines, so that the AC power will be given. Here the induction motor used is a slip ring induction motor. We are usually having two types of induction motor: squirrel cage induction motor and slip ring induction motor. What is squirrel cage? You know already. Here the rotor bars will be short circuited with the help of end rings. So no speed control is possible in case of squirrel cage. It looks like the cage of squirrel, and also no speed control is possible. So here we are mainly using this circuit for variable speed application, particularly in speed control application. That's why we are preferring slip ring induction motor. It is also known as wound rotor induction motor. Here we are having variable resistances, and here we are using the two device, that is two converters. One is a rectifier and the other is inverter. So rectifier is nothing but AC to DC converter. So the AC input given to the rectifier is converted into DC. Here we are having, it is a three-phase rectifier. Three-phase rectifier, here we have three phases R, Y and B, and mainly three phases mainly used for high power application compared to single phase. Whereas single phase we are preferring only for domestic application, whereas three phase inverter and all for higher power application we are using. So the bridge rectifier, it looks like the bridge, and here we are having 6 diodes. Diodes are uncontrolled device and it is used as a switching element. So here mainly this rectifier converts AC into DC, and here we are having smoothing inductor mainly to smooth the current in order to remove the ripple content, because DC always having ripple content. So the ripple content are eliminated with the help of smoothing inductor. So we are having a smooth current output, and that will be, here it is given to the inverter circuit. Inverter is nothing but DC to AC converter. Here we are using thyristor as the switching element. So here we are having anode, cathode and gate. So thyristor is a control device. So the output can be controlled by varying the gating signal. That's why it is a control device, whereas a diode is an uncontrolled element. Here in inverter we are using thyristor as the switching element, so that it converts DC input into AC. So the pumping back of power to the supply lines is possible with the help of this converter and inverter arrangement. So with the help of transformer we are pumping back again to the supply lines. So you know transformer already, it is a stationary device. It transfers electrical power from one circuit to other without change in frequency. So here we are using three-phase transformer because mainly we are preferring this for high power applications like industrial application, so that the power from the inverter will be pumped back to the three-phase supply lines. So this is the main idea about slip power recovery scheme. So instead of wasting slip power in the rotor circuit, it is again pumped back to the supply lines for useful power, so that the power is not at all wasted. It is again and again reused. That's why it is called slip power recovery. So here we have combination of, we are having a slip ring induction motor and a combination of rectifier and inverter. So induction motor, here we are preferring slip ring, mainly it is having variable resistance, so speed control is possible by controlling the current. And here we are having rectifier and inverter. So rectifier converts AC into DC, and further it is smoothened with the help of a smoothing inductor. So the ripples and all removed, and then it is given to the inverter. So the inverter converts DC input into AC output, and then further it is given to the transformer for stepping up the voltage, because in transformer we have step down transformer or step up transformer depending upon the application we are using. So here we are considering it as a step up transformer, so it will step up the voltage, and further it is fed to the three-phase supply lines grid. So instead of wasting slip power, we are using it in a effective way. We are pumping back again the power to the supply lines. That's why it is called slip power recovery scheme. Thank you.